The hidden secrets of space nebulas. One of the fascinating places in the universe is space. It's riddled with mysteries that we have only scratched the surface of. The nebulas, which are clouds of gas and dust found throughout space, are one such mystery. Scientists have been trying to figure out what they're made of for years, but no one has found any answers. At first glance, space nebulas may appear to be nothing more than pretty shapes floating around in the sky, but they're hiding some pretty intriguing secrets, which we'll discuss in this video. Space nebulas are breathtaking sights, from the Ring Nebula and Lyra to the Tarantula Nebula. Learn about the mysteries of these cosmic phenomena, which contain billions of stars and planetary systems. Did you know that a nebula can form from the death of a single star? Space nebulas are fascinating. In this video, we'll look into the hidden secrets of space nebulas, such as how they form stars. Are you interested in astronomy, cosmology, or simply learning more about our universe? Make sure to watch until the end of this video. Please give this video a thumbs up and subscribe to this channel for more content before we continue. Click the bell button to be notified of new videos. Have you already done so? Let's get started. What exactly is a nebula? A nebula is a massive cloud of dust and gas between stars and serves as a nursery for new stars. The term derives from the Latin word nebula, which means mist, vapor, fog, smoke, exhalation. Nebulae are composed of dust, basic elements such as hydrogen, and other ionized gases. They form either as clouds or cold interstellar gas and dust, or as the result of a supernova. Hot, young stars, for example, erode and sculpt the clouds in the Carina Nebula by emitting thick stellar winds and scorching ultraviolet radiation. The nebula's low-density regions are shredded, while the denser regions resist erosion and remain as thick as pillars. New stars continue forming in these columns' dark, cold interiors. A disk around the protostar slowly accretes onto the star's surface, doing star formation. A portion of the material is ejected along jets parallel to the accretion disk. The jets can reach speeds of hundreds of miles per second. When these jets collide with the surrounding nebula, they produce small, glowing patches of nebulosity known as Herbig-Haro HH objects. Who made the discovery? Many people can lay claim to discovering nebulae, as with most things in the heavens. The Crab Nebula was first mentioned in 964 by the Persian astronomer Abd al-Rahman al-Sufi, who wrote about the Andromeda galaxy and noticed a little cloud. Early Arabic and Chinese astronomers also noticed the Crab Nebula due to a supernova in 1054. Nebulae were discovered in the 17th century thanks to advances in optics. Nicolas Claude Fabry de Piresque discovered the Orion Nebula in 1610, later observed by Johann Baptist Cysat in 1618. However, famous scientist Christian Huygens made the first detailed observations in 1659. Huygens was also the first to publish a standard formula for centripetal force, which he did in 1659, so it's been a big year for Huygens. Edmund Halley wrote about 6 different nebulae about 50 years later. He was honored by having a comet named after him. Not really. He was a very accomplished scientist who served as Britain's second astronomer royal. However, famous people have gravitated to nebulae over the years. Edwin Hubble contributed to the classification of nebulae based on the light spectra they emit, as well as the discovery that nearly all nebulae are associated with stars and are illuminated by starlight. Is it visible to me? Some nebulae are so bright that they can be seen with the naked eye. One of these is the Orion Nebula, located between the stars in the constellation Orion's Sword. Many more can be seen through telescopes, depending on how many stars surround them and illuminate the dust clouds that form the nebulae. However, star clusters, galaxies, and nebulae are frequently difficult to distinguish due to their similar composition. Majestic Nebula's unknown secrets. A European telescope has captured the most detailed image of the well-known Carina Nebula. revealing previously hidden features of an exquisite star nursery. The European Southern Observatory's Very Large Telescope, VLT, captured the cosmic landscape of gas, dust, and young stars in the Carina Nebula, about 7,500 light-years from Earth. The vibrant star nursery is located deep in the southern Milky Way, in the constellation Carina, the Keel. The Carina Nebula's dynamic star formation provides astronomers with an intriguing laboratory to study massive stars' birth and early lives. A team of European astronomers led by Thomas Preibisch of the University Observatory in Munich, Germany, peered behind the thick clouds of dust to reveal the Carina Nebula's hidden secrets using the VLT's infrared seeking capability and the infrared Hawk-Eye camera. Many massive young stars are born in clouds of glowing gas and dust, and the nebula is home to several of the brightest and most massive known stars. According to ESO officials, Eta Carinae, one of these stellar giants, is a mysteriously and highly unstable star. Eta Carinae was the second brightest star in the night sky for several years in the 1840s, and astronomers believe it will die in a violent supernova explosion in a relatively short period. Trumpler 14, the bright star cluster near the center of the image, is a cluster of stars. According to ESO officials, this region of the sky has formed many individual stars and star clusters over the last few million years. What causes star formation in nebulae? Stars are born in gas and dust clouds. The Orion Nebula, a massive cloud of gas and dust many light-years across, is one such stellar nursery. Turbulent flow within these clouds creates high-density regions known as knots. These knots have enough mass to cause the gas and dust to collapse due to gravitational attraction. As it collapses, gravity causes the material at the center to heat up, forming a protostar. This core eventually becomes hot enough to ignite fusion, and a star is born. Not all of the material in the collapsing cloud becomes a star. The remaining dust may become planets, asteroids, or comets. Or it may remain as dust. Scientists' three-dimensional computer models of star formation predict that the spinning clouds of collapsing gas and dust will split in two or three distinct blobs. This would explain why the vast majority of stars in the Milky Way are paired or clustered together. Astrophysicists have used detailed observations and computer simulations to learn about the life cycles of stars, their chemistry, nuclear processes within them, and the nature of the gas and dust that stars form from. Known as the interstellar medium, or ISM, Hubble has revealed stars and planetary systems in the making by probing the intricate complexity of these environments. As revealed by spectroscopy, the chemical composition of stars is determined by the material from which they are formed. Stars formed in the early universe from matter devoid of most elements except hydrogen and helium. Nuclear fusion processes have created and continue to create the other chemical elements in the interiors of stars. That new material is eventually recycled into the stars and planets of future generations. Are stars born in clusters? Most stars form in multiple star systems, though the process of star formation has yet to be fully understood. The number of stars that form groups can range from a few hundreds to thousands. The masses of the stars in each cluster vary. The most massive stars are a few and far between, while the least massive stars are plentiful. Hubble has investigated star clusters of all sizes, employing spectroscopy to determine the detailed chemistry of star cluster members. Scientists using Hubble can determine the luminosity's intrinsic brightness and temperatures of star cluster members by taking precise observations. This contributes to a better understanding of star formation, stellar evolution, and the physics of theoretical models used to explain these phenomena. The most massive star clusters, which contain tens of thousands to hundreds of thousands of stars, formed early in the universe, around 13 billion years ago. These massive clusters, known as globular clusters, still exist today, even though the stars within them have evolved. Cluster properties are indicators of the earliest stages of cosmic star formation. Hubble observations have revealed subtle differences in globular clusters' chemistry and, in some cases, evidence that these clusters contain multiple generations of stars. How do stars die? When the most massive stars' nuclear fuel runs out, they explode in a spectacular display known as a supernova, leaving behind neutron stars, black holes, or nothing. Astronomers last observed a supernova in our galaxy in the 1600s. However, in 1987, light from a supernova in the Large Magellanic Cloud, one of the Milky Way's satellite galaxies, reached Earth. Hubble began monitoring the explosion, known as supernova 1987A, 3 years later, from the first ever ringside seat for a supernova. Hubble has reportedly observed the supernova 1987A nebula remnant, observing rings and knots of gas brightening around the exploded star. Observing the supernova for decades has provided a better understanding of how these events unfold over thousands of years. Smaller stars like our Sun die by ejecting their outer layers of gas into space over 10,000 years, leaving behind the star's hot core, a white dwarf. Radiation from the white dwarf causes the gas to glow, resulting in a one-of-a-kind and stunning formation known as a planetary nebula. The name derives from the early days of astronomy when observers suspected that the dim forms they saw through their telescopes were planets. Because we can see previously released material interacting with newly ejected material, Hubble's observations show that planetary nebulas form multiple outbursts, not just in one dying breath. Hubble has observed many of these nebulas and discovered a variety of complicated and extraordinary shapes, ranging from tunnels to interlocking rings. For example, the Cat's Eye Nebula is made up of 11 gas bubbles. The Helix Nebula appears to be a giant eye staring at us from space. The Red Rectangle, one of the strangest planetary nebulas of all, looks exactly as it sounds. Nebulae are some of the most beautiful forms in space. Nebulae are massive dust, hydrogen, and helium clouds formed by massive stars or failed stars. What happens to the majority of these legendary bodies? Space nebulas have become a dazzling part of the universe, but there is more to them than meets the eye. The video for today has come to an end. Remember to give this video a thumbs up and subscribe to the channel to see more content. Remember to click the bell icon to receive notifications when new videos are posted. For the time, I'll say goodbye and see you in the next video.